Welcome everyone to the ninth video in a series of videos on solar and wind energy estimation and forecasting application developed in MATLAB. I'm Kiran Gaikwad, the developer of the application. I have a Masters of Technology in Power Electronics and Power Systems from Sardar Patel College of Engineering, Mumbai. I'm currently working as a Junior Project Fellow at GERMI, Gujarat Energy Research and Management Institute under Dr. Sardar In this video, we will have a demo on the CP curve generator application. As we all know from the previous videos that the CP curve generator app is a part of the wind energy application, and here we are looking at the main window of the wind energy application through which we can go into each of the applications, but for this video we will click on the CP curve generator app. Okay, so this is the CP curve generator app, and before starting the demo I would like to make you understand what CP curve represents. So the CP is the power correction factor of a wind turbine blade. It gives us the fraction of wind power which the turbine blades can absorb as mechanical energy. It depends upon three factors: design of the blades, tip speed ratio, and blade pitch angle. Tip speed ratio is the ratio of the speed of the turbine blade tip to the wind speed, whereas blade pitch angle, it is the angle made by the turbine rotor blade with respect to the horizontal circular plane of rotation. Okay, so as we can see, we have in the first pane we have three options, three radio buttons which help us in computing and viewing the CP curves. So the equation 1 and equation 2 represent the empirical equations given by Anderson and Bose for modeling CP curves of wind turbines. And let us start with the mode 1, that is equation 1, and when this is selected we have option to enter the input variables. It's from C1, C2, C3, C4, C5, C6 and X are the design parameters, and these variables or coefficients depend upon the design of the wind blade turbine. Okay, then there are this number of rotor types is the number of different rotor types we can simulate in this application. So now it is at 1, so we will make it to 2, and all these values which are looking on the screen will always be populated as base values or default values. And as we have two rotor types over here, we will change the C1 value, we will append the C1 value to 1. Over here we will append it to maybe 150, over here to 1 again, C4 to 2, C5 to 20, C6 to 40, X to 1, and let the theta be 0. And as we have two rotor types and two coefficients corresponding to each of the rotor types, we can go ahead and compute the CP. So we will press the compute CP button, and this is the graph representing the CP or the power coefficient versus the tip speed ratio graph for the first rotor information. And if you want to see the next one, you will press next, and this is something like this because I have put in some random values and we see that it is quite a skewed graph. Okay, and it is because the design parameters are not properly fed. Okay, but we can see that we can go back and forth and view our computations. And now what we can do is we will go to the previous graph over here. Okay, and we can change the theta. Theta is nothing but the blade pitch angle from 0 to 1. And let's see, now we have, as we have changed theta from 0 to 1, we have to use the CP with theta change button, and we get a smaller CP curve. Okay, and as we keep on changing the theta, 1.5, we keep getting smaller and smaller values. Okay, so this is all about the equation 1, which gives us actually a lot of freedom to model our CP curves by tweaking with the C1 all these parameters from C1 to C6 and then the X parameter. And let us go and see mode 2 or the equation 2. Before that, we will reset the CP curve generator application and we're back to where we started from. Okay, now let us select the equation 2. Now this is the second empirical equation given by Anderson and Bose for modeling the CP curve for a wind turbine blade. And as we can see, all these values from C1 through X have been now disabled because we don't require them over here. What the input goes is the theta value, which we can change, and now we can compute the CP, and you will see this curve. So this curve is the curve for a generalized wind blade turbine as modeled by Anderson and Bose, and we can change the theta over here from to 10, and we can see the change in the corresponding CP curve. We'll go for 25. Okay, so as we can see, as the theta or the blade pitch angle keeps on increasing, we get a lower and lower power coefficient. Okay, what this curve means is that at this particular tip speed and for this particular blade pitch angle, which was 0 in the original case, will get the highest power that could be absorbed from the wind by the wind turbine would be at this point, which is around 11.5 or 12 on this graph. That is, the tip speed should be 12. And this CP curves are used for blade pitch angle control systems, which help in maximizing the energy conversion from the wind turbines. And that is about the equation 2. And we can just reset the application again over here, and now we can go to the third mode, which is the data mode. And in the data mode, what happens is that you don't compute the CP values because we have the data from the manufacturer, which we can load and which we can view in this graph over here. So let us load some CP curve data into this, but before that, let us see how the Excel sheet should be in order to load it into this application. So this is how the Excel sheet should look like. No headers. This is the tip speed and this is the corresponding CP. So this is how the Excel sheet should look like, so that we can input that Excel sheet into our application. And okay, let us go and load some data. Okay, over here, open. And as we have kept the rotor type number of rotor types to 1, we can load only one data, and once we hit next, we can see that CP curve data over here. But we can also increase the number to 3 maybe, and we say we want to import that data, and we go over there, start loading data over here. So we'll select the first file, that is this, open, and it will ask us again for the second file, and we'll go again and load the second file. Is this. Now it will ask us for the third file on its own. Yes, maybe this one. Okay. So now we can press next. And this is the first of your loaded files. This is the second one. This is the third one. And similarly, you can go to the previous one and you can just loop around. So that's about it. Okay. So we can now just reset this once again and we will get back to the equation 1 mode, and we can close this like that. And okay. So hence this application is useful to compute and plot wind power correction factor versus tip speed ratio or wind speed curves using the empirical equations given by Anderson and Bose. Also, it can be used to view CP curve data stored in Excel sheets as graphs. Thank you.